been a long weekend here for King's birthday. I was hoping to get more done on the Riley with the brackets for the rear guards. I haven't actually managed to do that at all. I have been doing other things though. I have finished my little bandsaw mounting box. I didn't have any steel plate in the end. I just went with a timber top and a piece of flat sheet steel over that. That should be fine. The only problem I've got, the reason I can't finish this is, despite all of the nuts and bolts I've got metric, I've got imperial, I've got UNF, UNC, all sorts of things. The one I do not have are M5 countersunk bolts to go in here, and they'll go through there and hold the bandsaw in place. Other than that, this is finished. That actually works reasonably well. I did use these longer bolts, which obviously don't sit flush, but I was able to test cutting something with those in place. So that's done. Currently the control box and everything is in the back of that. The MGB, the rear springs are off. I need to get under there and give everything a good clean, make sure the rear axle oil seals aren't leaking too badly. I think they're just weeping, so I just need to clean that up a bit. The leaf springs are packaged up, ready to be sent off. I did ring one of the local MG part suppliers up in Auckland, and they were a bit slack, to be honest. They never really got back to me. They were supposed to ring me back. I rang them a few times. The people weren't there, and I'm not sure they're going to be able to tell me what I need to know anyway. So the way they advertise new MGB rear springs is they'll tell you how much drop they give you, as in 2-inch or 1-inch, but they don't tell you what the free camber is, the initial starting camber. And that's what I wanted to measure on a new set of springs. But I think on my car, even the new springs are still far too arched. And the reason is because this was originally a rubber bumper car. The rubber bumper cars were raised in height to meet the US crash regulations in the 70s. And they actually shifted the front mounting point for the springs. It's lower down. So the only way you can really get the height correct on here without messing around with the springs too much and changing spring rates and things is to have them reset. So that's what I'm going to do. These were originally reset, but I believe that was done cold, not reforged and then retreated. So I'm sending it off to the same people who did my Riley springs. They worked out great, so they will be able to rebuild these to exactly the spec I want. Basically what I want to do is raise the back of the car about 1.5 inches. It's not a lot at all, so they just need a little bit more shape put in them. And that's so little shape that everything else will still fit on the car. The shackles will all line up. It'll give me a little bit more clearance around the bump stops, that kind of thing. So yeah, I think 1.5 inch lift on that will be fine. And the other thing I did, let's see how windy it is out here. It was a horrible day yesterday, so I was in the lab the whole day playing with chronometric instruments. I've got a lot of little films about that. I don't know how good they are because it's really hard to film small things accurately like that. The other thing I did is finally fixed the peeling clear coat on the Land Rover. I did a kind of hack job. I didn't do it properly, which would be strip everything back to metal and repaint it all. All I did was wet sanded away the flaky clear coat, touched it up with some color match paint, and then put another layer of clear coat over the top. And I just want to prevent it from being flaky at the moment. It still needs polishing back a bit. The whole vehicle's filthy. I've been playing with my polisher thing, but I think I really need to do a really good sort of strip wash on it to strip all the old wax and grease and all that kind of stuff off it. Then I can go over it, give it a go over with a random orbit polisher, and then just wax it. Apparently with this clear coat I used, you're not supposed to wax it for, I think it's at least a month, to make sure the solvents were all completely cleared up. So The polisher works pretty well. I've been trying to get some of the scratches out of the side of it. We did once take it down a sort of four-wheel drive track and the side got all scratched up. So it's not looking too bad. It's looking better than it was, so that's fine. And I think that's kind of it for me now. It's back to work tomorrow, unfortunately. Yesterday was a very wet and rainy day, so I actually ended up flitting backwards and forwards between Big Shed and my lab, and I started tidying up and having a look at these chronometric speedometers that I've got. I've ended up with 3 of them, and they're all different. One of them is the one I got most recently at the swap meet, which is a very early kind with the nice aluminium bezel and the beveled glass. That would be a nice one to get going. But I've sort of been looking at these things and cleaning them up and understanding how they work. There's lots of articles online that kind of explain it. They mainly go into the escapement part, which is this part, which is the bit that does all the clever stuff. It's a little clockwork mechanism. It's quite convoluted. If you're not an expert at clockwork, I imagine it's hard to really understand what's happening, but the explanations you find online are pretty good. So those are easy enough to take apart. So the way this works is you've got this base piece, and this is where the input comes in, and the input drives the little mileometer. Now there seem to be different variations of this mechanism as well. So I think this is an early one, and it's got a different arrangement for how the numbers move around. It's not quite the same as the Enigma machine. It's got this sort of ratchet mechanism here, so we'll make some room. As this gear spins, it's going to be really hard to show. I can't really show it working with one hand, but as the input spins, it turns this gear, and this is actually on a little eccentric. So this is what's pushing around the little gear here. And the way this works is there's a shaft that goes all the way through the middle, and the shaft is kind of keyed. It's got a sort of slot all the way down one side. You can see the slot there. And the drums with the numbers on them aren't keyed to the slot, but in between each drum there's a little metal washer that is keyed to the slot, and this gear is keyed to that slot. So as this turns, this shaft turns. And the way it works is there's little catches here, and normally these drums are prevented from turning by these little springy fingers that apply friction to them. And as they turn, there's little ramps on them. You can just sort of see them. They push these out of the way. That lets the drive, just via friction provided by the spring in the end here, turn the wheels. That seems to be how it works. But the interesting thing is there are 2 different sorts of mechanisms. So this is the earlier one as far as I can tell. And this one, it actually, you can see the lowest value drum moving as the car's moving. So it's continually rolling around. There's a second type, which is later. It's got the same sort of input shaft and little eccentric there with a spring, and the little pawl mechanism up here to push the wheel round. But this one has a different mechanism. There's actually sort of metal plates that go in between the drums with a little pin on them, and it works in much the same way. It's still all kind of friction drive, but on this one the number actually ticks around every mile. It's not continually moving the first drum. So when I first put it back together, I thought maybe it was broken because this wasn't working, but it's because it clicks over all at once, more or less. It doesn't continually drive around. I took these all apart, cleaned all the old grease and crap out of them, just clean these with soapy water and a cotton bud, nothing more harsh than that because I don't want to wreck the paint. In the side here, they all seem to have this. I think that one of these is upside down. but underneath this little brass cover there's a felt pad, and there's a hole that goes through to the drive shaft. So that gets filled with oil, and then the little cover put on, and that's what oils the input shaft over the life of these things on this piece. And I just used a few drops of very fine oil. I didn't go anywhere near the drum mechanism, I just put some on the little eccentric. There's probably proper clock oil that you can use for this, but I don't know where to get that from. It seems hard to get. So I'm using this, it's light gear oil. It's actually for model railway locomotives. So I think that should work okay for this. And you only need a tiny amount anyway, you're not drowning it in oil. So these escapement mechanisms all seem much the same. This is the one from the gauge I most recently got, I think. It's hard to remember, but this one doesn't work at all, and it didn't take me too long to figure out why. If you look at it, there's no connection between the input and all these drive gears and this shaft in the middle, and it's because it's actually missing a whole gear, which is that gear, big gear on the bottom you can see in the middle, which is what takes the drive from the input across to the little balance wheel thing, the little escapement. So this one's no good, it doesn't work, but it's probably good for parts. I don't know if I could 3D print a gear for that, maybe, probably not. But it was good to play around with how to clean it and how it worked without ruining a good one. To clean these, I've used a combination of I put them in the ultrasonic cleaner with some dilute cloudy ammonia solution. That got most of the junk off them, just these mechanisms. And then I put them through the ultrasonic again with clean water, and then I took them out from there, dried them off with compressed air, and then I used lighter fluid, sort of a combination of lighter fluid and isopropyl alcohol to clean them off with a cotton bud. And again, using compressed air from my little airbrush compressor. That worked really well for that, to get them all nice and clean. And then these have a couple of points you have to oil, just those little places there, I think. And it literally just takes, it's less than a drop of oil, it's the tiniest amount of oil, and that seems to be all they need apparently. So these mechanisms, as far as I can tell, are interchangeable. There are minor variations in them, I think. So what I'm trying to do is put together one decent gauge. I think I might actually be able to get two good ones, and ideally I can get one nice one in the early style case. This is the one that I got originally, and again you can see this is different because it's got the trip meter. So it's just an additional piece of mechanism. This one I haven't taken apart and cleaned. Now I've done the other two, I'm pretty confident I know how to do that, and I can do that safely. So I will strip this one down and give it a good clean up. The problem with this one is there's quite a bit of wear on that input shaft. I don't know that you can fix that. Well, I don't know if I can fix that. I'm sure somebody could fix that. So I'm not sure if that's too much of a problem. The other two seem much better. So it might be worth, this one's really good. So it might be worth rebuilding it with one of the ones that doesn't have the trip meter. The trip meter would be nice though. So yeah, they're interesting little devices. It is worth being aware though that the mileometer things are different across different types. The clockwork mechanism bit seems to be the same, and that comes out with one screw. So there's one screw on the back there, and this whole mechanism just pops out. It's really simple. Getting the drums and things off, I'm not sure I recommend that. If it's working, it's probably best to leave these alone, because reassembling this is a real pain in the neck. And you can actually see how they've changed the design over the years, I'm assuming, one, to give it that different behavior where the lowest wheel just ticks over every mile instead of continual, and two, probably to make them easier to assemble and manufacture. So this one, you can probably just see, so the shaft has got this sort of slot all the way down it, and this one also has a ring cut out of it, which is how it's locked in place. You can see this little metal plate holds it in place because it fits into that slot. The problem is that slot makes it really difficult to try and assemble all of this. So you can just see at the end there that kind of washer. So those washers are keyed so that they rotate with the shaft, and there is a washer, a spring, a washer, the drum, another washer, drum, washer, drum, washer, drum, washer, all the way along. And the only way I figured out you can assemble this is insert the shaft through from this side slowly and put those washers and drums on as you go. And the problem is when you get to the end here, those little washers will slide over this little end piece and then catch in that slot. So it was really fiddly trying to get it all back together. This one isn't quite as bad. The way it works with these sort of ring pieces that go in the middle, there are little pins on these, which is kind of how the drive gets transmitted from drum to drum, but that wasn't too bad to reassemble. It's just really fiddly. This one, I do know how to do it now, so I might actually do that, take it apart, because if somebody has oiled these in the past, one of these was fine, but the other one had a lot of gunk in between the little drums, and I think that would cause problems. So I'm going to take this one apart. Because this one has the two sets of drums on it, it's got a different faceplate because of course it needs a little window for each one. I do have this one, and this is the one on the gauge I got most recently, I think. That one's well knackered, so I should have enough parts here to make two good gauges, which is what I'm hoping. So yeah, really interesting little devices. The little clockwork part's quite neat, how it works. Like I say, there's explanations online that go into it a lot better than I could. So I think I'm going to carefully take this one apart and clean it like I have with the other two. The faces I just clean with a little bit of soapy water and a cotton bud. You have to be really careful with them. I think the lettering will come off quite easily, and they do start rusting. I've touched up the paint on this one just a little bit. I'll just touch up the lettering just where it was starting to rust under the paint, so I sort of scrape that off and just put a little bit of paint on it. The cases should come up fine. I'll probably put those in the evaporust. I'll take out the little windows and the sort of paper gaskets in the bottom. The other problem I'm going to have is these input shafts are different to give you different turns per mile. So it's a bit hard to see, but there's usually a number on the middle of the gauge. 6280 turns per mile. I don't know if this one's going to be readable. I can't tell what that says. And this one, that was a bit hard to read as well. So you have to get the right gauge for your car, and I'm guessing in the Riley, because the speedometer pickup comes off the torque tube. There's a gear on the middle of the torque tube, and I don't know what the standard speedo ratio is for different size differentials, because I'm guessing that makes a difference. So your speed is going to be determined by the size of the wheels and the tires you've got. Your diff ratio, I think mine's 5:1 from memory. So I'm guessing the speedometer is going to be out. Now I think you can buy gearboxes. I think you can have them made specially, possibly, which corrects the gear ratios. So I'm going to have to figure that one out. The other thing is these are in miles, and I need it all marked in kilometers anyway. So, you know, the other thing that might be possible is reprint the face. So actually redraw the face and tweak it so it just matches, so the speed you're going actually matches the speed on the speedometer. Yeah, I'm not sure how I'm going to deal with that, but I need to get one working first anyway before I can do anything. This is just to show how it is literally one screw that holds the little clockwork mechanism in place into the base. That's the base there. Even though it is really hard getting these back together, I probably will strip this one down. Yeah, still don't know if that's a lot of wear in there. Unfortunately, no, possibly. I think what I can actually do is, this is my other early mechanism, and it looks like the bases are interchangeable. So it should be possible for me to take all of this and put it onto this base, which is, there's a little wear in there, but not too much. So I'm going to clean these up and strip them down, but it looks like you can mix and match parts. As far as I can tell, the bases, which seem to be some sort of die-cast horrible stuff, are interchangeable. These two are definitely both later ones. There's no markings or anything on them. So that should be doable, I think. Okay, I've started taking this apart. They come apart really easily. This one is all gummy. You might not want to watch this if you are mechanically squeamish, but if I can carefully it's a bit tricky with one hand, maybe we can do it from the other direction. So now there is nothing holding this shaft in, so if we pop that out, you can see how the shaft is now loose. If I pull this out, yeah, you can see all the oil and crap that's on there. Now this will probably all go sproing, and then I want it to all go sproing downwards. Here we go. So you can see there the little rings with pins on them, that I guess they're working as clutches, and they stop, or rather they allow the little drums to move around. And you can also see all these little washers. So between each drum, there you go, see the little washers. This is the gear that the little eccentric pushes around. There's another one of those washers, and there's a little drive thing. So this is the little cam that actually moves the first drum around. And then I haven't exactly worked out how it works. You can sort of see the little track in there that the little pin thing moves in. It's quite clever, but I haven't exactly figured out how it works, how these little rings which are on springs, how when the pins make it move, how that transmits the drive from one drum to the other. It is just through friction, I know that, which is why you've got the spring. And you can see the shaft there, possibly. It has that little groove in it, and each of these washers has one of those little grooves, so it'll only fit in one way, like that, and then it's captive on that shaft. And that's why reassembling this thing is a real pain in the neck. But the reason I wanted to do it was to get in here and clean all of this gunk out. I don't know if there would have been any lubrication on these originally. I suspect not really, or the tiniest amount of oil, but I'm pretty sure these are meant to run fairly dry. I don't know what sort of metal these are. In the earlier one, in that one, the little washers were actually brass, but in this they seem to be steel. I have a magnet handy to see if they're stainless steel or not, or if they're magnetic or not. So, got that apart. I'm going to take apart the other drum in here so I don't mix up the parts, and then I'm pretty sure I can transplant the parts from here onto this one, which would be good. So I have the mechanism from the one I'm just doing is in the ultrasonic at the moment. So this is the little trip meter side undone. The little ratchet there works the other way up, so instead of pushing it on this side, it's pushing it from underneath. Unfortunately, when this all sprung apart, I didn't quite notice where some of these parts went. So that's going to be interesting when I put it back together. But it's not too hard to figure it out. There's only really one way it can go. The other interesting thing is these ones have these spring steel plates, and this brass gear here actually fits on this plate and under this little springy tab, so that provides a lot of friction there. The other side has one too. And that, so when you assemble it, as well as trying to get everything on the shaft, you have to get it under that little thing. It may just be that I'm assembling it the wrong way around. These shafts come out, all of this comes apart as well, but I assembled it with that all together. Maybe that's not the right way, but it did work. I did get there in the end. And this little eccentric thing unscrews as well, so this is threaded in. It's very thin, but you can actually just get a little tiny, it turns out to be 4mm spanner on there, and you can undo that, and then you can pull out this whole little eccentric thing. There's little springs on everything. This also feels very gummy. It's all gummed up just through age, I guess. The other thing I wanted to show on this is, so this is the little brass cover, and I just sort of flick that out with a scalpel blade. Like that. And you can see underneath there is a felt pad. Get that out. Well, this one's very dry, which will explain all the wear. So there's a felt pad. Lighter fluid is really good for washing these out. And then inside, right inside there, we probably can't see it, there's actually a little hole, and there is another little piece of felt or foam. Yeah. So I'm going to focus on it. And that goes down into the little hole. So that goes down into the input shaft. So that's, I think that's probably the only bit on this that is supposed to have oil in it. Again, I can put this through the ultrasonic. I don't do that for the drums because I'm worried about the paint coming off, so I just clean those up by hand with soapy water and a cotton bud lots of cotton buds, because they are filthy. So I'm working on swapping over the mechanism from this one where the input shaft is worn out over to my spare one, and this is going pretty well. I've managed to get the little eccentric pawls in place. They're all sort of hooked down. And it was going pretty well. I've figured out how this goes back together. I more or less know how the little ratcheting mechanism works. So if you look at one of the drums, they've got two sides to them. There's a little ratchet on one side and a little sort of track. You can just sort of see that on the other side. And that's what these little springy things with the little pins run in. So that kind of runs in that track. And you can see there's a little sort of lump on one side. And what happens is those pins, it kind of follows around. And when it reaches that and it lifts the little pin up, on one side, the pin then transfers that motion through to the little ratcheting mechanism on the other side, and that's what lets them engage, I guess. It's something like that. It's a little bit hard to see how that works. One thing I had to do when I looked at my little film is, if you look at the way these are, the pins can go either way. They could either be on the top or the bottom, and of course that's going to make a difference. And luckily I had taken pictures and film of which way up the ones on this side go. They go similar to this, with the pins up here, not down here, if that makes sense. So it was all going well. I'd figured out exactly how this all goes back together. There's a sequence of washers and plates, and some of them are effectively keyed onto the shaft and some of them aren't. There's this little spring plate which is all kind of friction driven, and of course these have to go in between the drums, so I have to take this apart again. The reason why I haven't taken it apart is because I discovered the housings are not exactly the same. Because this one never had the trip meter, the little screw holes here aren't tapped. So I'm stuck at the moment. I need to get a suitable tap. You just know this is all going to go on the floor at some point. I actually vacuumed up in here today to make sure the floor was clean and there's no little bits of wire and things, so if I do drop anything it's easy to find them again. The reason you need these tapped holes is because you need these little plates that fit in place and hold all the shafts in place, basically. So this one actually needs the other little piece on it first, which I need to clean. So that's this piece here. Let's put it there, which is the trip reset lever. So it's a little bit hard to see, but there's a small gear here that goes on the end of the shaft here when it's all assembled, and that's what lets you reset that trip meter. So the problem is I need to tap those holes. Something I can point with. This is the screw, and I believe these are probably 7BA screws. Now the screw next to it is a 2.5 millimeter, and you can, the threads are almost interchangeable, and it's actually very difficult to see if it's 7BA or 2.5. This is a 2.5 screw and a 2.5 nut, and they are kind of compatible. If you put the 2.5 screw into the threaded body, it is a little bit loose, which is why I believe it is actually 7BA. So I really need to see if I can get a 7BA tap because I don't happen to have one. That could be tricky. I don't want to have to order it from overseas for one single little tap. If I really have to, I think I can probably thread it 2.5 metric, and that should work. So I'm a bit stuck with this one at the moment. I'm going to keep assembling it as much as I can and see if it actually works. I think I've got as far as I can this weekend now. Obviously I can't screw this on yet until I tap that hole, but this shows how the little reset mechanism works, the trip reset. So this shaft is attached to this gear, and there's this little plate, and sort of underneath there's a little sort of acorn shaped thing, and what that does is as you pull the shaft in and out, it moves this little arm, and what this arm does is it pushes on the little lever. So as you pull the reset knob, it pulls this lever down, which disengages the eccentric pull, and it moves the gear into mesh with the gear on the trip meter, and then when you spin it, it lets you reset it. It's quite neat. There's a little spring at the top here that puts spring tension on here. I can't reattach that until this is all finished and bolted in place, of course, screwed in place. But yeah, it's quite neat how this all works. You can sort of see how that little pointer means that this can move while still allowing the gear to rotate. Very cool little mechanism. The other thing I discovered that was wrong on my broken one is, if you look in there, that top wheel is the one that the needle's attached to. You can see that pin that goes up, which transfers the motion into that needle pin. And on my broken one, that pin's actually missing. You can see where it's broken off. So as well as the missing gear, that pin was broken, so this one would never work, but it's good for spare parts. The way it disengages this mechanism is this rotates and drives that one of those gears, but on the back here there's this little spring, a little cam thing, and what that does is it moves that gear out of engagement. So that's the portion that makes the needle stop moving or fall back. So that moves out of alignment, so the drive is disengaged temporarily, and that's all driven off the clockwork. And you can see the little mechanism in here that would normally be driven around that sort of bottom gear. And yeah, really neat little mechanism, quite convoluted. This bit on the back is just the little balance thing. So without that gear in the middle there, the drive hasn't been transmitted to the clockwork. That's why this one doesn't work. And these little springy levers, I guess, just work as clutches or brakes on those other gear wheels. Very cool little thing. So after I cleaned these, I was a bit worried about them rusting, because it's all just steel. So I think I mentioned I cleaned it with some dilute cloudy ammonia in the ultrasonic cleaner, and then from there to just clean hot water in the ultrasonic, and then I cleaned it all down with lighter fluid and isopropyl alcohol, and then I actually gave it a spray with this stuff, which is for electrical contacts, and it's a clean and lube, and it stops things rusting. So I sprayed that on it and then air dried it with my air compressor, my little airbrush, And I think that should work okay. It doesn't really leave a lot of lubrication there, but I'm hoping that's enough to stop it all rusting. I think that'll work. So until I get these, until I can get a tap to tap these, the body, I can't really put this back together. So I guess I can work on the case. This is the second mechanism I've got. So this one is also complete. It's interesting that these have different constructions as well. So you can see that one's got little metal plates in there. This one looks similar. This one has just a little brass disc type thing. So I'm not sure which one of these I'll actually use in here. As far as I can tell, these bits are identical, I think. My parts muddled up. But as these are, as I mentioned, only held in with one screw, I can assemble the thing and see which one works best. Hopefully they both work identically and they're both good now. Yeah, interesting little instruments. It's notable that I haven't actually found any instructions online for how you're meant to assemble or disassemble these. They just don't. I think most people just don't bother. And there are animations that you can find on YouTube as well that show yet another sort of mechanism for how this works, where the clutches and things are sort of built into the drums. It doesn't have these little springy pieces. Very cool little devices. It'd be interesting to know how many different variations there are.